This presentation is about 6 distinguished individuals inducted into the American Association of Drilling Engineers, Fluids Hall of Fame, Class of 2016.
The Hall of Fame was created by the AADE, Houston chapter, in 2005 to recognize and preserve the legacies of key individuals who have contributed to the advancement of oilfield fluids technology. In doing so, it seeks to elevate the images of the different fluid segments in the oil and gas industry, by highlighting contributions of its distinguished men and women. In 2014, the Fluids Hall of Fame was officially opened to those representing drilling, completion, cementing, and fracturing fluids.
The class of 2016 includes the following extraordinary individuals, in alphabetical order.
Claude E. Cook, Jr. Inducted for his many contributions to cementing technology, and pioneering development of hydraulic fracturing fluids, including the invention of ceramic propents.
Kelly B. Fox. Honored for his pioneering work on synthetic polymers for brine viscosification and friction reduction in coil tubing, and fracturing fluids.
Arvind D. Patel. Inducted for his extensive research into shale inhibition, pioneering use of amines in clay control, along with innovations in reversible invert emulsion drilling fluids.
Stephen C. Polnosic. Inducted for his field application of water-based environmentally friendly drilling fluids encompassing shale stability, horizontal and HTHP applications, and admirable leadership of API Committee SC13.
Ronald E. Sweatman. Honored for his significant contributions to the advancement of cementing and other well services through patented technologies and numerous publications.
And Mario Zamora. Inducted for his pioneering work in hydraulics and rheology, barite sag, and software development, and his leadership role in the fluids industry.
Honorees in 5 previous biannual classes include the Class of 2006, the Class of 2008, the Class of 2010, the Class of 2012, and the Class of 2014.
This is the group picture of the Hall of Fame Class of 2016. These are members of the AADE Fluids Hall of Fame who attended their April 12, 2016 reunion in Houston.
But it seemed to me that the most important problem in fracturing was proppant. We were still using sand for proppant or glass beads. I found out the glass beads were no good, and sand crushed pretty badly. Kept looking until I found the centered bauxite materials that would be a good proppant.
The other area of polymer development was for a high temperature thickener for the very heavy brines. This polymer was proved to be very useful in the very high temperatures in the very heavy brines, the calcium bromide brines and calcium chloride brines. And it was tested to 500 degrees and proved to be quite stable.
Most of these products I prepared or I came up with, there are several of them. There are 2 or 3 of them are very proud of it. And one of them is a synthetic base fluid. The synthetic base fluid I developed, I patented it also, and that came from the interesting work. And the work started, this was in the early 1990s or maybe late 1980s, when we were using the oil-based drilling fluid that was mainly based on a diesel-based mud. So the environmental concerns were there at that point.
I was dealing with these organometallic materials in graduate school that were sensitive to air and water. Here I was working with this mud out in these gigantic pits, out in these oil rigs, and like, whoa. But I learned my business and got pretty good at it. From there on, it was an interesting career in many, many ways because I initially did a lot of rig work and did a lot of good work solo. But over the years, over many, many projects, I got to work on these multidisciplinary teams.
There's not many people that realize that we did the first horizontal wells that had the multiple fractures offshore in the North Sea in the Danish waters where they had similar formations to what we have over here in the USA. And they found that when they did that, they could save $500 million by not building a platform and simply going horizontal from one platform quite a distance away to drain all of the areas in that reservoir.
Some of the projects that I did through my career in IMC, which later became MI SWACO, pretty much paralleled the roadmap that the industry was doing over that period of time. And it also followed the technology that was being evolved.
I really am from India actually originally, and I did my high school and the undergraduate degrees in India, and then in 1968, I moved to America to get further education and graduated with master's degree in organic chemistry at Stephen F. Austin. And then I went to Denton, Texas to get my PhD. After my graduation at UNT, which is University of North Texas, I did some kind of postdoc work at University of Texas Medical Center in Dallas. And I found a job in Philadelphia in Cancer Institute. In '78, after 4 years at Foxy Center, I moved to College Station to get a job in university. That's where I was a research associate first, and for 3 years I was a lecturer and professor in organic chemistry department. In 1981, January, I started my industry job with Megobar, and I worked there for 34 years.
I was born in a hospital in Nanticoke, Pennsylvania, near the small unincorporated entity called Alden in Newport Township, Luzerne County, northeastern Pennsylvania. Went to elementary, middle, and high school there. Went locally to undergraduate at Wilkes College, Wilkes-Barre, Pennsylvania, and then went on to graduate school. Finally chose Cornell from that nice choice of schools, mainly because of the largeness of their inorganic chemistry faculty. Had dreams of becoming a college or university professor. I wound up getting playing interviews with 3 companies, and out of those 3 companies, I only got one job offer, and that was with Texaco in Bel Air, Texas. That year, 3 of us came down from Cornell after finishing up our degrees, and I was the last of the 3 to show up. So I got the job the other 2 guys didn't want. I got drilling fluids.
Well, I grew up in South Louisiana. My father had worked in the oil field all his life. He kind of put that into my blood, you know, by taking me around all over the place in South Louisiana to show me what the oil field was all about. Well, I started after, you know, majoring in chemistry at LSU. I worked as a chemist for an oil field cement manufacturer. So I got into the cementing fluids with that company. I did apply for a position that was open as an engineer trainee after that, and worked my way up through the ranks, you know, to become one of the cementing specialists in the world. That, you know, I just finished a book last year on cementing.
I was born in Matamoros, Tamaulipas, Mexico, and 11 months later my family immigrated to the U.S. in Brownsville, Texas, and that's where I grew up. After I graduated from Southmost College, I went to my favorite school, the University of Texas, where I received a Bachelor of Science in Mechanical Engineering in 1967. I had worked the 2 previous summers for Shell in West Texas, first at the No Trees TXL plant, and then later in the Midland office. So I was so impressed with Shell that when I graduated, I came to Houston and really never left, and became a drilling engineer in the Houston division. Unfortunately, we had a downturn around 1971 that's very similar to the one we're going through today, and they shut down the Houston office, moved everybody to New Orleans. I was one of the guys that stayed behind. Fortunately, I was able to get a job with IMC Drilling Fluids. Now, I had originally wanted to work for Magabar because Bill Ream, Hall of Famer, he was my hero. I just loved the work that he was doing and abnormal pressures and well control. Now, surprisingly, when I was interviewed for the job at IMC, Doyle Waller said that he wanted to start an engineering group. And it wasn't until years later that I finally realized that I was hired to be the Bill Ream of IMC.
I was born in the oil field in Arkansas, born in a hospital in El Dorado. My daddy worked for Magnolia Petroleum, which became Mobil. I went to school originally first grade in Sandyland School, which was out in the oil field between El Dorado and Smackover. My mother thought I needed to go to a better high school, so the 11th grade I hitchhiked to high school in El Dorado. And then my dad got transferred to from the Arkansas oil fields to East Texas, and we moved to Kilgore. I only had to go 1 semester in Kilgore to finish. Midterm went to Tyler Commercial College, got a degree in accounting because I thought I could get a job bookkeeping while I was going to college, and started the fall at Kilgore Junior College for 1 year, and I got my BS degree in Louisiana Tech. I decided to major in physics. By then I decided I would go to the University of Texas. I spent 3.5 years there, got my PhD in physics, and I was ready to go to work. And in the meantime, in the summers, I'd work for Magnolia in their field research laboratories in Duncanville, just outside Dallas. And I always thought when I got out of college, I'd go to work for Magnolia. But Humble offered me $5 a month more than Shell, so I decided I'd go to work for them. Plus, I knew it was a good company. So I went to work for Humble in Humble Production Research in Houston in 1954.
I was raised in California, in the San Francisco Bay Area. My family moved to Arizona, to Phoenix, when I was a senior in high school. My first degree was Bachelor of Science in Geology I obtained from Arizona State University. After high school, I started at the university and spent a year, but it was a little early for me, so I went in the Navy for 4 years. I graduated in 1978. I went to work for Dow Well Division of Dow Chemical, and started out in Sonora, Texas. I learned to operate all the equipment and cementing, stimulation, and those kinds of things. I was there for 8 months, and then I transferred to Palestine, Texas. After Palestine, I spent a little time at the research center in Tulsa. I spent a year in Midland, Texas, working with an engineering group there, the Dow Well engineering group, primarily designing cementing and stimulation treatments. And from there, then I went to Hobbs, New Mexico, and spent a year in Hobbs. After a year there in 1981, I transferred back to Tulsa to the research center that Dow Well had there. Got involved with, primarily with acidizing and other stimulation. I obtained a second degree later on in life, and a degree in chemistry from the Oklahoma Wesleyan University there in Bartlesville.
First, I'd like to compliment the AADE on the new group of Hall of Fame inductees. They have been outstanding. This year, inductees are super special, particularly now that we've opened it from drilling fluids. We're now doing fracturing fluids and cementing and completion fluids.
It started in about 1957 with Humble Oil Company, and some of the people that I early on met there were some of the people that are now in the Hall of Fame, like Claude Cook was one of the very first people that I interviewed, and Leon Robinson was there. I really admire the young people who are out there right now coming online and achieving all these things. But I'm also really glad to see that the AADE is recognizing some of these people for what they've done.
We have a really good turnout here with a lot of students, and we have a lot of the representatives of the different companies here in Houston at this meeting. And then you put that on top of that, well, you put the Fluids Hall of Fame and the new inductees there, and you get to hear about, you know, what these people have done over their careers, and you just can't be anything but impressed. And some of them I knew better than others, but you know, they're all really profound adders to the technology.
My first 3 years with Dowell gave me a lot of field experience and helped me appreciate the types of problems that were encountered on a daily basis. You know, the rest of my career was really spent in research and development. At Dowell, I specialized in acidizing, and one of my first projects was the introduction of xanthan gum into the industry as an acid thickener. I had opportunity to work with several other polymers in that same type of application, and one of the products that we worked with was a polymer that was developed by Drilling Specialties, which was a division of Phillips Petroleum at the time. That proved, you know, fortuitous to me later on, because in 1986 I got laid off from Dowell. And along with a lot of other good researchers, I got to go to work for Phillips then, and it was a wonderful career change.
In the beginning, we started with abnormal pressures. We were plotting pressures from logs. We were doing well control training. We developed a D-exponent slide rule, and then later we developed a well control simulator called the IMCO BOSS. That was followed by the deep drilling that was being done in Oklahoma. In fact, when we drilled at the time, which is the world's deepest well, the Bertha Rogers #1 went down to 31,441 feet. We decided to try to improve what we were doing in modeling the pressure losses in the annulus. And in, I believe it was 1974, David Lord and I introduced the Herschel-Buckley model to the industry.
Because of the environmental concern, there were some environmentally friendly fluids they were looking and all this thing at that time. So Halliburton was promoting and kind of using this petro-free system, and it was called petro-free system because it was not derived from petroleum. It was derived from natural products. They made the fatty acid esters and they made the fluid out of it, and it was used. And it enjoyed its success because it was biodegradable and it was not petroleum free, so it was more environmentally friendly. However, there was one catch to that system, that it was not performance friendly. So I developed poly-alpha olefin based drilling fluid, invert immersion drilling fluid, which I patented it. And this system was given the name synthetic base mud, and after that lots of people worked on it, of course, to come up with a lot of synthetic base material which are not actually distillate from petroleum.
Over those 25 years with Texaco, I received quite a bit of recognition. In my first 2 years there, I got what they colloquially referred to as the Young Buck Award. It was a $5,000 check from the head man in the company for doing some kind of outstanding work. And later on in Texaco, I got some awards for increasing the values of reserves. I think in the early 2000s I got an award for teaching excellence in the drilling fluid school that my colleague Jim Headley and I oftentimes presented together, or sometimes if it was overseas. Other firsts, I was actually the person who was involved with selecting and supervising the drilling fluid for the first horizontal well in the Gulf of Mexico, which was drilled by Texaco. And that was, I think, in 1990.
And so I was out on a field operation to help convert an a producing well into an injection well. And I had to do a sand control operation on that. And we did that operation, and they woke me up really early in the morning and said, "You need to come and look at this well." And what we had actually done was perform a hydraulic fracturing job on what we thought was a depleted well, and turned it into the highest producing well in that field.
As we got into the horizontal drilling, we got involved with hole cleaning studies, and then barite sag, and then because of the use of these synthetics offshore, we started looking at ECD and the effect of temperature and pressure on rheology and density, which led to more computer developments.
Well, I went to work for Humble in '54, and I was assigned a project on to a new method of removing heavier hydrocarbons from natural gas. And it didn't look very promising to me after a year. So I moved on to oil recovery and worked on that for another year or two, and I decided we probably weren't going to develop a process that would be economic. I got interested in cementing, various aspects of cementing, testing for cement, determining if there's flow behind casing. I came up with the idea of a logging tool to measure temperature inside casing, to making measurements, and saw some very interesting data, and I published that in the SPE, and that's probably the most quoted paper that I ever published.
Since 1986, I worked with drilling specialties there in Bartlesville. Worked on a variety of products. My first project was to develop polymer thickeners for heavy brines, heavy brine completions fluids. It was a fascinating area of study, the heavy brines, some very interesting chemistries. One of our first developments in that area was a friction reducer, which was used in coiled tubing operations. Later on, it became widely used in the coiled tubing operation. We expanded its use into the heavier brines.
Neat projects I've worked on have been a series of high-temperature water-based muds offshore Mobile in federal waters where the bottom hole temperature was around 400 degrees Fahrenheit. And we eventually sussed out a system that worked like nobody's business. And the third well that was drilled was completely without any delays or incident, whereas the previous two had some pretty severe bumps in the road.
Along the way, we developed these little chips for the TI calculators, the 58 and the 59. The first one was developed by Roger Blyer, who worked in my group at the time. And it was called Drill Mod. And one time, a customer came up to me and he wanted to thank me for Drill Mod saving his father's life. He said his father had retired, and in 3 months his health was really on a downturn, and so he bought him a Drill Mod. And he started playing with it over and over again, and he lived another 5 years.
I'll never forget going to Alaska to do an operation for the first time. So I grabbed a sample of the drilling fluid and went over to the, which was a water-based drilling fluid, and went over to the mud scale and poured it in there. And this is all outside, you know, real cold, and I wasn't expecting for that fluid to turn into solid ice. It was pretty surprising. I actually had to get a blowtorch in order to unfreeze that sample out of that expensive mud scale.
I was Society of Petroleum Engineers distinguished lecturer years 1995 to 1996, and so I got to travel to some more even exotic places that I'd never been before. On that trip, I got to go to the Philippines, Vietnam, 4 places in India, and 2 in Pakistan.
There was a product, it was a defoamer, which was patented and was used in Canada. So they said, okay, we need this product and we need to have something to develop some product for us, and we need it now. The idea is to make a product which can instantly spray the aluminum stearate on the surface. I took 4, 5, 6 beakers, put it on a bench, put water on it. I found out that one of the surfactants I had in the lab will do exactly what the patented product was doing. So it was just simply blending a surfactant, polypropylene glycol, and aluminum stearate. I blended it, done it, sprayed it, done. And that product, even today, we are selling in the drilling fluid industry as a best defoamer on the market.
I got a telephone call one time out of the jungles of Africa. They were drilling a well, and this was a major oil company, and they said that the work that we had done in de-exponents saved their well and perhaps their lives. They were looking for a transition zone and were plotting de-exponents, and it wasn't changing. The slope of the overlay was at an angle, and it showed that the pressures were increasing with depth. So they immediately shut down, ran casing, waded up the mud, drilled 50 feet, and took a 1 pound per gallon kick.
I did get to spend some time though running casing with these temperature sensors on it. The first time we ran this casing was on King Ranch. The roughnecks kept setting the slips on the cable. We had a cable going down outside the casing. You had to be careful when you set the slips on that casing. The roughnecks had never done anything like that before, so they cut the cable several times, and we had a cable splicer out there, and by the time daylight came, we had kind of educated the crew.
Come up with a drilling fluid system for a rank wildcat in Paraguay, where the geoscientists were in charge and basically put all kinds of horrendous limitations on the drilling staff. They said, well, we're going to drill this wildcat well with a coring rig, but we're going to need a little elevated incident fluid, but you can't use barite because the coring rig will sling the solids out to the side and basically ruin logs and a bunch of other things, possibly get the core pipe stuck. Can't use salt because that's going to mess with our logs, but we want you to find something to increase the density. Talking to various people, and it was actually Ron Bland with now Baker Hughes Intech, or actually retired from them, who suggested I look into sorbitol, which is a sugar that basically find in chewing gum. And it's a dense organic liquid, and it was water soluble, and so we actually weighted the mud with a sweetener.
I know one time I had this epiphany when I was on vacation during Christmas time, and I'd seen, yes, a virtual colonoscopy. And what they were doing is taking an MRI and thin slices, and then they stuck them together like slices of bread, and they created a 3D image. And I said, that's exactly what we can do with what we're doing in hydraulics and the downhole environment. So I went to a guy, his name was Doug Simpkins, who was a mathematician, an excellent programmer, but he had a passion for graphics, and it was an incredible success.
Looking back at the sort of what I consider the older generation, there's the late Don Weintraub, and I think Jay Simpson is still with us. Those two gentlemen were intellectually without peer, but they were nice guys and always willing to answer a question honestly and give a helping hand when necessary. And those two kind of served as role models for, like, this is how you want to be as a professional in any industry, but for the particular drilling fluids industry.
There have been so many mentors. People like Fred Grocock and Saeed Ali and people like that who who were quite patient in working with me to develop new ideas and new processes. You know, people like Dustin Free, you know, who was my manager in Midland, took me under wing and helped me a lot in my development there.
Well, early on, you know, as I started off as a district engineer and then went into what we call a regional engineer, I had a engineering supervisor or manager that his name is Jim Ritter. He's passed now. He passed most, or not most, but let's say a good bit of that to me, and I'll always be grateful for that. And then later there was a person by the name of Claude Cook that worked for Exxon, and he was in the research department, and he had some very interesting research work that, you know, I would call on him to learn all about that, and he shared quite a bit with that research work, and it helped me a great deal to understand some of the things that were new to the business that we did not realize.
Kind of moving down to folks a little closer to me in age in my generation, there are two names that I wound up narrowing the list down to, one of whom was also honored with me here today, Mario Zamora, and the other being Ron Bland. There were two guys that you could go to and ask some of the most difficult technical questions, and they would give you clear, understandable, straightforward, honest answers to the extent that they were allowed by other companies. And I've always enjoyed interacting with those two gentlemen. They were, once again, just people that I could rely on.
I've always had good experience in working with people in the industry, you know, both my peers and my supervisors. I've had a variety of different working conditions there, and early on I was always impressed by the supervisors on location and the level of expertise that they had, and their willingness to mentor. A wonderful management in both the companies that I worked for that were very supportive of research and product development.
Until the very last year, I only had 5 bosses: Bob Jones, Doyle Waller, Roger Blyer, Monica Norman, and Jim Bruton. And they gave me almost ultimate freedom to innovate, to create. They supported me in writing papers, supported me in joining and being active in societies in the industry.
Intriguing projects that I've worked on have been with Lindsay Fraser, who's been with a variety of companies over the years. He's somebody who I always admired his pioneering spirit and his looking for something that will work under some pretty difficult circumstances.
Well, certainly was one of the ones more important was the fellow who hired me for Humble, a fellow named Claude Hocott. He was the assistant head of the research group when I went to work there in 1954. Hocott was a really fine fellow, and he influenced me not so much by preaching to me or telling me things, but just by watching him, how he behaved, and it was we had a good group, absolutely. Ethics was just a given.
Well, I have met a lot of people over the years. I mean, they may not have made it to the Hall of Fame, or some of them might have. For example, Mario Zamora has made to Hall of Fame, and I have worked with him for like 25, 30 years almost, because since MI got together, he came from IMCO side, I came from Megabar side, and we worked together. And Mario Zamora had impacted me quite a bit because he was quite a senior to me at that point, and he was very knowledgeable and known person in the drilling fluid industry. And I have learned quite a bit from that, and he had a lot of philosophical ideas about what to do, what not to do in the drilling fluid. But the other people who has impacted me is Emmanuel Stamatakis, We always worked together. We had a lot of good times together. From beginning, we had made it sure that, Arvind, when we retire, we'll retire together.
I forgot to acknowledge my colleague of many years at Texaco, Jim Headley. It is always humbling to work with somebody who's smarter than you, more gracious than you, and just, once again, never had any barriers to working with you. A lot of companies know about people are very competitive, and that was something I didn't have to worry about at Texaco, and that really made my life and career there much more enjoyable.
We worked a lot just because we were interested in what we were doing. It affected my family, but not like the people who've traveled all over the world and lived all over the world. I really admire them because they've had quite a different life. I was in Houston the whole time except 1 year.
So I'm retired now, so out of 4 brothers, we are all 4 here, but 3 of us are retired, 1 of them is still working. I had also my parents lived with us. Of course, my mother passed away a couple of years ago and my father had passed away earlier, but we 4 brothers are there. We all have kids. I have 2 sons. One is doctor, one is a computer engineer.
Those early years were tough, but a lot of you can identify with those times. Later on, when I went to work in research and development, it became much more a regular type of job. But in the last 15 years or so, the need for me to go traveling diminished considerably, and I became much more of a regular family guy,
I moved house, or let's say resident locations, 11 times in my career, and ended up in Houston. I think the wife, since, over there, when you're an expat, living in a foreign country, you get to do things. The bad thing was actually having to leave some of the places that we really liked and move to some places that we had no idea whether or not they would be any good, and go through that process,
Well, anybody who did the kind of work that we did traveled internationally a great deal. And so during those times, sometimes as long as a month, even longer, they had to survive on their own. Fortunately, my lovely wife, Bobby, managed to keep everything together, and the kids survived and they grew up. But I can assure you that it's a lonely, lonely time. Now, when we were traveling, we had a great time, but returning home, and thank God that they were able to keep everything together.
Well, the fact that I don't have a family shows how, because of the field work I did, sometimes I'd get a phone call, and a couple hours later I'd be packing a suitcase and going off somewhere, and I would be gone for 6 weeks at a time. And let me tell you, that takes a toll on any kind of romantic life.
Well, they're very proud that I'm receiving this kind of an honor. It was quite a surprise to me, and it was a surprise to them too. But yes, they're quite proud that the work that I did in the industry is being recognized, and I'm receiving this honor.
So I think that if they understand that coming into the industry, that the oil industry's got that cyclic nature, if they can understand that there's going to be those types of situations in most industries, then that should kind of smooth the pathway a little bit into the oil business, because there's going to be some more good times to come for sure.
Well, there's no doubt that this is 2016 and we're going through an incredible downturn. However, this is not our first rodeo. But the way I look at it, it's kind of like the stock market. The stock market has its ups and downs. And so you have to be in there for the long haul. So what I would suggest to anybody who wants to be in the oil industry, particularly in drilling and even in drilling fluids, is to recognize that it's not going to be perfectly smooth sailing all the time, but when times are good, they are very good.
So we know things will change. They always do. We just don't know when they're going to change. And so all we can do that are in the industry is to, continue to do our jobs, continue to be as positive as we possibly can about where we're going as an industry, and look for the better days that will eventually come. And looking at these students that are here, well, those are going to be the better days. Those are bright, bright people.
So much of life and career is a matter of chance. And just like I told you, I got the job that nobody else wanted, and when I first had it, I didn't think I wanted it either. And it just turned into this incredibly rich, rewarding career for me.
Well, the one thing about, to go to any industry, one thing is that if you are dedicated, if you are really into it, if you put your mind into it, you're going to be successful.
I would think there's no other industry that I've ever heard of that would be more interesting, with more diversity. There's so much to learn.
Find a company that will appreciate any passions that you have. I had a passion for working in sort of research, innovative work. And so I found a company that let me do that. And I had the time of my life.
Industry presented me with so many opportunities to grow and expand my career path. Many of those I let go by because my interests were were in other directions. But frankly, there's very little I would change. It was a great run.
Find your place, find your subject, keep searching around till you find one that really turns you on, and then put yourself into it and work very hard.
But for those people who are talented, there are so many challenges and neat things that can be done and that still need to be done. And you just never know what's going to happen. You think, oh, this is a very mature industry and people already know how to do everything. I can guarantee you there are still combinations of situations out there that nobody has yet faced, that these young people are going to have to face, and they're going to have the times of their lives.
So it doesn't matter where you work or what you do to young people. Yes, you have to have interest, fine. But once you join, you have to think that this is it. And if up and down comes and you only think about the money, well, you're not really going to get there. You're going to get there if you prove that you are valuable.
But we all know that it really takes longer to get things back going again than it is to stop it. But it will happen. I wish I was smart enough to give some idea as to when it would be.
I think you have to approach it the way we approached it. Is we expected to work very hard.
There's so much opportunity out there. This is an industry that will survive, it will last, and there's lots of opportunity for those people that are just now entering the industry and for those who are here.